This is the second part for the electrophilic addition on this conjugated diene. We're going to look now at what's happening when it's the purple double bond that react. The initial step is the same, no difference. We get protonation of the purple double bond shown by the electron attacking from the double bond to the electron deficient proton. Formation of two intermediates. No change in the carbon architecture of the compound. The green double bond in this mechanism is not affected. So what we have addition of the hydrogen at this position or this one here. So the two carbon are potentially protonated, giving rise to different intermediate. In this particular case, there's very large difference between the two intermediate. This one is a tertiary carbocation with 3 electron donating group, whereas this one is a secondary carbocation. One key theme here is the fact that we deal with conjugated addition or conjugated diene. So one of the carbocation here has possibility of resonance with the double bond. So that makes this carbocation allylic. Being allylic is more stable than the secondary carbocation. We already knew that because it was a tertiary carbocation. So that means that this intermediate is formed in minor amount, a negligible amount, doesn't matter. The reaction will continue with the tertiary allylic carbocation. So what we can draw now, because it's allylic, there's possibility of resonance, delocalization of the electron, forming a compound with similar carbon architecture but different electron positioning, which is one key thing in resonance. So that would now migrate the double bond between these two carbon, and the carbon here is losing electron, will now have a positive charge. So we get one intermediate, two possible resonance form. We're going to look at the detail of which one is preferred later. But being systematic and looking at all possible products, so we can have bromination of the two resonance form, giving two different products. So in the first case, we get this bicyclic compound with 2,5-member ring. Second case, same carbon architecture, but different positioning of the double bond in the bromine. So the double bond here stays at the same position, and the bromide is adding on the tertiary carbocation. That's one possible product. The other product here has the double bond remaining there, and the carbocation being brominated, addition of bromine. Two products are formed from protonation of the purple double bond.